So I'm going to talk a lot about service-oriented architectures today based on whatever I've learned and how I've seen the architecture evolve over the period of time. I'm going to talk a little bit about services and when you look at them from different aspects, sizes, and sometimes by functionality. And we're going to go through some definitions for me, which is very important because when you're trying to invest into something, you really need to understand what you're investing in. And then I'll wrap it up with some key takeaways. All right, so let's get started. Now, even before I have my first slide, I put a warning slide up here. I want to be very clear. I'm not here to have a sales pitch for service-oriented architectures or microservices. There are no silver bullets. If you think somebody comes and sells you that we will break your application into these amazing services, which will be the solution to all your problems, that's not the case. You really need to take a step back and understand what problem you're trying to solve and what solution fits into that. So when I put this slide up, I said, maybe there are examples out there on the internet. Let me go and search some popular examples of where people have gone down a particular path and then decided to take a bit of a U-turn or think again. And I came across 4 popular ones, of which I'm going to talk about maybe 1 or 2 depending on time. Amazon Prime Videos. They started off with microservices as their base architectural pattern. They did a great job at it. They were domain experts. They knew what they were doing. And they built a fairly good system. But then they started having performance issues. And when they went back to the drawing board, they realized a monolithic approach works better for them. Right? So it's always about trade-offs. Another very popular example is Istio control plane. So they started off again with microservices, and then they realized they don't really need any of the benefits that come with it. They're fairly happy with a limited complexity and living with monoliths. And they rethought their architecture, started from scratch, and Istio D was born, which is a monolithic architectural pattern. So whatever you'll see in the next slides is really definition of some of the new evolutionary patterns, but by no means is it's a sales pitch telling you it's going to solve your problems. And that needs a different discussion. All right, let's get started. So what are service-oriented architectures? This term was coined back in 1996. It was coined as part of a white paper published by Gartner analysts. And essentially, the definition said that this architectural style is what supports service orientation, i.e. service as the basic building block of the architectural pattern. And they then gave a definition to what services are. So they said, a service is essentially a logical representation of repeatable business activities with a specific outcome. So now, if I was supposed to build a bread baking service, essentially that service would bake a bread every single time. I'll tell it to build a sourdough, it'll bake a sourdough. I'll tell it to make a white bread, it'll make a white sandwich bread. And that's it, it's going to repeat that activity. In itself, it'll be self-contained. So it may rely on other services to get data, such as a recipe service to get the recipe. But the core task of baking the bread would be contained in this service. And then it could be composed of other services. So for those who've ever seen a process of bread being baked, or those who've had somebody in their family who's passionate about baking breads, you start by mixing ingredients. Then you let your mixed ingredients sit for a while, which is called as proofing. Then you basically bake it, and then you cool it. I could have all of these as separate services. I could have a mixing service, a proofing service, a bake in the oven service, and a cooling service. But overall, it composes of the bread baking service. And finally, it's a black box to the consumer. So I may have some interfaces that I can use to talk to this service. So I can say, bake a bread. So I'm giving it some inputs. It will say, yep, accepted. I'm going to bake a bread. I might come back and say, what's going on with this bread? And it may say, oh, it's in the proofing process. So it will give me some visibility on what's going on. But how it does its core task is completely contained in this service. So that's why it's called a black box. Now remember, this term was coined in 1996. So it was the first formal architectural style that supported service orientation. Now, do I think that it got really popular at that time? Not really. In fact, it led to a lot of ambiguity. So again, as I was putting this together, I tried to understand why did it not get that popular. Clearly, we're following this pattern in the industry as a norm now. So what happened in 1996 that it didn't really kick off, and how come it's more popular now? And I realized that the interpretation of the definition got lost. So even now, if you go and kind of do a quick search or use your ChatGPT to compare a service-oriented architecture with microservice, you would see all kind of interpretations. There was one I remember on a very popular site which said, service-oriented architectures assume services will share a database. And I was like, that's not what the definition said. So yes, there was a lot of ambiguity. There were articles about the ambiguity. But I think for me, what was the key thing here was this led to a lot of other popular architectural styles that exist today and actually got adopted in the industry because they were a bit more prescripted around the decision, and they started understanding to solve a problem. You just can't say a service will solve your problem. You need to add a bit more depth to it. So with that, let's look at these evolutionary architectural styles, first by size. Okay? Now, there are two popular sizes in services that anybody would have heard of. Monoliths. Anybody have heard of monoliths? Microservices? Yes. So those are the two popular architectural styles. Now, one may think, why am I going to talk about monoliths a little bit today? But I'm going to put a pin to that question, and I'll come back to it. So monoliths, just by the definition, simply are a single unified code basis. So when you are writing code for a monolithic architecture-based application, it's in the same code base, gets deployed as a single deployable, is owned by one or more teams depending on the size of the organization, and essentially it's one service, right? When I say monoliths, often a lot of people think it is legacy, but it is not. Even though these terms sometimes get used interchangeably, legacy application or software code is one that is very difficult to change, maintain. It is very difficult to understand. If anybody was in the previous session that Ben was running and you looked at the code, that code looked like Harmony. You can, even though you've not worked on that code, you could read it and completely understand what he was talking about. So that's not legacy code base. Legacy code base is one which you read and you pull your hair apart. So when I speak of monoliths today, I am particularly speaking of what I prefer to call as modular monoliths. Modular in the sense that a monolith itself will be composed of modules, very well-defined modules. So let's again look at it as an example. I think I'm baking really good breads, and I want to now probably start my own micro bakery. And I think I should automate it because I'm a software engineer, so probably I should. And what does it look like? So if this is what my monolith was supposed to look like, those modules there, order module, production and kitchen module, inventory module, and supply chain module, are achieved by the means of folder structure by convention. And these modules are fairly self-contained. They talk to each other over clearly defined interfaces. They don't just call a random function there without thinking how it will, and the code is not mishmashed. And typically, these modules are defined against a boundary, a domain boundary. In the domain-driven design perspective, I can't say DDD because of the name conflicts. Say, when I want to do anything to do with my order, let's say when I'm taking order from my local businesses so I can bake bread and serve them, I can use my ordering module to create orders, manage orders, update orders, cancel them, and it's all contained in that. The order module might then say to the schedule in the production and kitchen module, you need to schedule something so that Garima remembers to break it and keeps her promise of the time that she has to deliver the order that she has promised. My kitchen and production module might take care of things like, I have a limited set of equipments at home. How do I best make the use of that equipment? How do I schedule the orders I'm taking in the most efficient manner? And essentially, they all share the same database. So that's what a monolithic architecture in terms of code base looks like. If you go back to the example we spoke about Prime Video, you can easily imagine Amazon Prime Video's team would be a huge team. And if they're working on a single code base, and that pattern is successful, that means it's easy for them to work on this single code base because they follow the right patterns of domain boundaries. They have great conventions around the code. They have great CI/CD pipelines supporting them. In fact, if I go back to the first company I worked in, it was a monolithic Ruby on Rails application. We were a team of, I think, 30, 40-odd people working on the code base. We clearly worked against certain modules that were closer to the teams we aligned with. And we used to deploy multiple times in a day. It was breeze to work with that code. Like, I remember snippets of that code off the top of my head even today, after so many years, just because it was simple. With that, let's move on to the next one, microservices. Now, microservices says your software system or application should be a collection of services. So going back to the service-oriented application definition we looked at, we are basically saying it's service-oriented, i.e. service is the basic building block in your application when you think about microservices. Though the definition of service here is a little bit more prescriptive. So let's go through it. Loosely coupled, i.e. every service that you're developing is loosely coupled to every other service. So if you go in depth of this specific pointer that is called out in the definition, it implies that these services talk to each other over a lightweight communication protocol, which could be your HTTP, asynchronous eventing mechanisms, and they don't, like, they're not, you don't have to make sure that to push this code base, I have to make changes to this, and they have to be absolutely coordinated, which is where it folds into independently deployable. They're organized around single business capabilities or domain, exactly how I was explaining the modules in the previous slide. And finally, they're often owned by a single small team so that they can autonomously work and develop this code base. Now, this definition was coined by Martin Fowler from ThoughtWorks. And again, if you go in depth of this definition and read a little bit more, you would realize that an important thing that they're trying to convey here is you want to be able to get all these teams to work independently and deploy their code bases independently. So if I was to redo my bakery management system again from scratch, using microservices as the core of it, that's how it would look like. So the modules you saw on the other slide are essentially domains here, and each domain may have one or more services in them. So the ordering module, where I said I manage my orders that I take from the local bakeries that I supply my breads to, I can manage them in my ordering service. And I can manage my bills and receipts for my previous history, so I can make sure I'm filing taxes at the end of the year correctly in my receipts and billing service. And then, again, similarly, some of the other domains. And now, there are amazing articles around monolith first on the web. A lot of people have written the same. A lot of time as a small company, especially if you start trying to innovate and figure out whether your product will work in the industry, start from monolith first. And as they scale, they see if they really want to adopt this pattern, right? And if you're doing modular monoliths right, the modules come out as microservices. It's easy. If it's not feeling easy, you're doing something wrong. That's the rule of the thumb. If it doesn't feel easy, there's something wrong, and you probably need to visit your design boards again. Now remember, I said put a pin on the question on why did I talk about monoliths and service-oriented architectures. What typically happens in medium to large scale organization, and in fact, even in small ones, there are things that add value when you do it from scratch in-house, but there's some things that can add value if you just buy them off the shelf. Like Ben was talking about Pinch, which was a payment provider. So many people have solved the problem of payment provider. Why would I build it from scratch for myself? I can use Pinch, I can use Stripe. There's so many companies out there that I can use, and I do not have to build it from scratch. Similarly, if I was doing my bakery management system, I realized I'm not a mathematician. I would not know what's the best algorithm to be able to make the best use of my production equipment. But maybe there's somebody who's done this job for me, who's a mathematician, and I can probably pick up the scheduling part of it, the production and equipment management, which maybe have some cool IoT kind of stuff off from the market, right? So here, essentially, I'm building things that are more valuable to me, that I want to build more, that I want to build the way I would prefer them to be. But I can always use certain things which could be open source, which could be commercial, off the shelf. OK, so these are services by size. There was one more. If I get at the time, I'll cover that. Otherwise, I'll skip that one. With that, I want to move to functionality. So size is one way of looking at things, right? Monoliths, microservice, simple, makes sense. Another way of looking at it is functionality. If you think about your application landscape, you have a UI, which is your layer via which user interacts. Then you have an application layer under it. Then you have a business domain layer under it. And then you have the DB layer under it. There's so many different layers, right? So why not start thinking about architectures and how architectures fit these functional layers? So the first one I want to cover today is micro frontends. Now, this is a little bit more newer kind of architectural style. I think I've seen a lot more talks about it in the last couple of years. Probably it's 7, 8-ish years old. Again, similar to service orientation, if you think about it, it says you have independently delivered front-end applications that compose the whole. So your overall UI is essentially composed of smaller front-end applications that your team members work on. Now, each of these applications is independently deployable, is loosely coupled to other front-end applications, and is often owned by a single small team. Just see the parallels that you are seeing in the definition we saw for microservice, in the definition we saw for service-oriented architectures. If I was to draw a Venn diagram, they will all overlap. And yet they'll have their own unique characteristics they're starting to bring on the table. Now, with micro frontends, a benefit that it started bringing, especially for large-scale organization, it might make sense for one team to choose React as a framework for them to develop their micro frontend. For another team, it makes sense probably to use Angular, right? And a pattern like this, or even microservices, if we go back to now, because you've broken your whole down to parts, and each of the parts is a service, gives you independence to start choosing technology. And I'm going back to my warning slide, because with all of these benefits it's bringing in, allowing team to work at their independent pace, letting them choose the technology thereafter, there is certain cost attached to it. How many technologies is good enough? If I have React, Angular, Vue, different versions of them, would it not overload my front end? Would it not have performance impacts? So whenever you allow these architectural styles to come in, while they offer their benefit, they need a very lightweight governance or some kind of guidelines to allow your company to function in a manner that is scalable and sustainable. Sure, let's say that personally, let's say if I was supposed to allow this in a medium to large scale organization, I may say, looking at the current lay of the land, I'm happy for having React and Angular as long as my team makes sure all the micro frontends are on the latest or latest -1 version. And that way, I've said, you have the option to choose and upgrade at the speed that you can, but these are the basic rule set or guidelines that we'll all adhere to. So that's micro frontends. Now, again, how would micro frontend look on my bakery? Now, right now, my micro bakery I spoke about was catering to B2B. So I got a call, I was recording things, and I feel like I'm getting really popular here. So let me go and create a website where I can take orders from local customers as well. So I create a website. I've called it Bake and Bite after my Instagram channel. Do not Google it. It's not the best of cakes out there. But anyhow, so what happens here is, let's say this part that you see, which is the sourdough bread area, the header, the image that you see, the description is coming from the product micro frontend, which is responsible for everything product. The related items you're seeing is coming from a recommendation micro frontend, which is then saying, oh, if somebody's on sourdough, they're more likely to buy this homemade jam of yours. So I'm going to start kind of recommending this homemade jam. And the add to cart button is probably coming from, let's say, my checkout micro frontend. So I've broken my micro frontends down. Each of them are living in their own repository and deploying independently. Again, I would not do it if I was a single person running a website. I would have been far better off having it as a monolithic application, but this is for hypothetical sake. OK, so that's how a micro frontend would look like. Micro frontend, also, again, with a lot of these patterns, you need key enablers for these patterns to work and scale in production. If I were to have, let's say, 30 teams working on different micro frontends, and each of them had come up with their own style of how a button should look like, my website will not give a consistent experience to its users. There was a talk this morning by Will and Joshua around design system library and how it really helped them kind of build together a cohesive UI. That's a great enabler for this pattern to scale and be sustainably adopted in production. Now, the layer right under it, called as backend for frontend, is another architectural style. Now, this layer is typically tightly coupled to your micro frontend layer or channel. So if you're not going the path of micro frontends, rather your team has gone down the path of different channels. Let's say you have an iOS application, an Android application, a website, and all of them have different code bases. A backend for frontend pattern could either align to micro frontends or could align to these channel code bases. So what's the problem backend for micro frontend? Backend for frontend truly solve? Again, the definition is very similar. Again, it's typically independently deployable, owned by a small single team, mostly the same team that owns the channel or the micro frontend. So the problem it typically tries to solve is if you have a mobile application versus a website, the real estate you have on these channels is different. You probably have a much smaller real estate on a mobile application or an iPad as compared to what you get on a website in a laptop. So now, when you are getting all the same payload from your backend service, which is, let's say, a list of 20-odd fields, I probably might just filter down 4 or 5 odd for this one thing and display. So my product information that you saw on the micro frontend previously, maybe on the iOS channel, I would not display the ingredients, let's say, right? So I want to optimize the payload coming to the mobile. It will help one in the network calls that the mobile is making. So maybe rather than making 5 different calls, getting this data from 5 different services, plugging it together, and each of the services returning 20 fields, 100 fields coming back to the micro frontend, I say, I'm going to make one call to my backend for frontend, get it to aggregate all this data for me, and return me the only 10 fields I need. And that's the kind of problem backend for frontend truly solve. They help you manage your payload sizes. They help you optimize the network calls your devices are making. And they also then help you to orchestrate some really complicated experience scenarios. So what does a backend for frontend look like in an architecture? So here what I've done is I have a mobile backend for frontend for iOS and Android. And I have a different backend for frontend for my website. Now, you don't necessarily need a backend for frontend. While I'm advocating for each of these patterns, I'm also trying to get you to see when and when you will not use it. So if my website is going to use all that real estate and going to show most of the data, I'm not doing anything typically interesting I don't really need a backend for front-end. So it's okay in scenarios where you feel you want to have a backend for front-end for mobile, but not for the website. And I've seen successful patterns in one or multiple companies where when we were aligning to digital channels, we've chosen the backend for front-end pattern typically for mobiles, but not website. And at a different company where we had micro front-ends, what we ended up doing was some micro front-ends were very complicated. They were doing a lot of, if user clicks this, then do this, etc. And you had to do it for both iOS and Android. So we just aligned our backend for front-end to take care of that aggregation logic, and immediately we were able to reuse that across. So even with backend for frontend, let's say, if I had this pattern, the one that I have on the screen, and think of a scenario where I want to now allow my customers to be able to make payment with gift cards on the website. So I want to accept up to 10 gift cards on the website, and then split payment with a credit card. Let's say if the gift cards are not sufficient to fulfill the total payment that needs to be charged. So what truly needs to now happen is, if I have multiple backend for frontend, or if I do not have backend for frontend, let's say iOS, Android, and web browser, I need each of those channels or each of the backend to frontend to say, charge this gift card, charge the second gift card, charge the third gift card, so on and so forth till the 10th, and then charge the credit card. Oops, the credit card payment failed. Release the payment, release the payment. You can asynchronous, like you can release them in parallel, but you have to make sure all the 10 payments get released on the gift card, so you're not holding that payment and making the gift card unusable for the person despite them not being able to purchase. That logic is now getting duplicated in all these layers. So even though I have these patterns, not really solving the problem. So another pattern that got created to solve that kind of problem was experience service. You don't need a backend for frontend necessarily if you don't feel that will solve any problem in your scenario. What you can, in fact, have is if you have only one or two extremely complicated experiences, you can, rather than going down the path of backend to frontend, you can say backend for frontend. I'm saying that wrong. What you can say is, I'm going to just create, let's say, a payment experience, which only solves problems for experiences which are extremely complicated, and I'm not going to worry about the others. Like, why create services when you don't need? You don't have to go overboard with any of these things. Just the right amount is the criteria to success. So they are neither complementary or supplementary to backend for frontend. They're completely exclusive. So you can decide both of them to coexist if it makes sense for you. You can decide down one path, or you can decide down the other path. What would these look like in a production architectural pattern? Essentially like that. Again, I'm saying you don't necessarily need to have the BFFs. You have payment experience. A checkout experience could also be another experience which is fairly complicated. You might offer same-day delivery. You might offer next-day delivery. You might offer click and collect. You may want to allow people to say, these two items I'm going to click and collect, this one deliver at my place. So some experiences are extremely complicated. Some others where you just want to show account details and editing them will remain simple. You never want to create such elaborate services around those patterns. All right, so with that, let's go to the next pattern, domain services. Now, I feel, and this is my honest opinion, domain services is a play on the whole concept of microservices. What happened when microservices got introduced is everybody just started saying, I have microservices, because this service looks much smaller than this old code base I had. It probably has much less lines of code. Let's call it a microservice. And I'm going to ask this question here. How many of you have seen that pattern in your actual production applications? I can see quite a few hands going up. That just shows that despite that pattern being very targeted to solve a specific problem, went to become a really, I hate to say this, but commercial buzzword that a lot of consultants started selling to solve your problem and give you the silver bullet. I feel this play is actually a fairly good play on microservices. What it has done is it has explicitly put the word domain in the definition by putting it in the name itself. So what has happened is, when you say I have a domain service, you truly have to think, do you have a domain service? And you cannot just say this is a domain service, because it must be a domain service for it to be a domain service. It's in the name. And this one will be simple: payment API, checkout API, ordering API, product API. Going back to the first monolith architecture slide that I spoke about, it is pretty much the modules we spoke about. So what I've done through looking at service orientation by the lens of functionality, I have been able to say there are layers. Each of the layers now have come up with architectural patterns that can solve it by splitting and making it a smaller kind of entity to deal with. Now, am I saying, again, going back to my warning slide, am I saying this is solving your problem? Maybe yes, maybe no. And that needs a design board. So with that, I want to go to the key takeaways. Make sure I'm on time. The first key takeaway: each architectural problem, pattern that I spoke about today addresses different problems and offers unique advantages. So as we went through those definitions, even in the definitions you saw, they were targeting a specific problem, and they were trying to solve that problem by bringing some unique advantages on the table. If you have that problem and you think these advantages would be helpful, maybe that architectural pattern is worth considering. But think about my words. I said maybe, because there's more to it. The reason it's maybe is because with each architectural pattern also comes trade-offs and enablers. Trade-offs is upfront costs that you know you would have to incur, right? And enablers are ongoing tools, techniques, and patterns you would need to support that pattern in a sustainable, scalable way in production. So if you were to invest in micro front-ends and not have a design system library, you can go and look at a lot of websites where you'll have 20 different variations of the button, and it would not feel like a cohesive website. Similarly, when you think about monolith versus microservices, you may think microservices looks like it is giving me all the advantages I need, but truly when you have a monolith, you have one application to deploy, one CI/CD pipeline to worry about. You can actually have transactions in production. When I say transaction, essentially, you can say, I want to do these 5 operations. Operation 1 should happen before operation 2, should happen before operation 3, 4, 5, and any one of them fails, you roll back all the other operations. Doing that in a microservice architectural style, which is by the nature of it distributed, comes with its own challenges. Now, those challenges are solvable, but it is a slightly different way to approach it. My take on it is, you've probably heard of this very popular law: energy can neither be created nor can be destroyed, but can be transformed from one form to the other. It's true for complexity as well. Complexity can neither be created nor it can be destroyed. You continue changing it from one form to the other. Mark and Mosley wrote an article, I don't know even in what year, but about complexity, where they spoke about accidental and essential complexity. And all of these, how you do technology, what's your architecture, how do you purpose it, it's all accidental complexity. Once you've taken a business problem and implemented it, you have accidental complexity. You're going to carry it. You're going to probably change it from code to infrastructure, but it's going to exist. And again, I can't emphasize enough how much you need enablers. If you're going to have services, and if you're lucky that your full company decides to adopt that pattern, it can go from 1 and 2 to 100 and thousands easily. You need to think about how these services will talk to each other. You need to have east-west traffic management in place. You need to have observability in place. You need to be able to understand how would you do service discoverability. How would eventing look? And if you not solve this problem, signing up for service-oriented architectures is just going to make your problem one problem to the other problem. It's not going to solve a problem. It's just going to change the problem that you're working on. And my final takeaway is ill-informed or conflicted interpretations of any of these lead you to a bigger chaos than where you started. You're dealing with one monolith. How bad it could be. You're going to deal with 100 of those in a few months' time if you make wrong decisions one after the other. I think the whole concept of DDD, and in fact, the book Eric Evans has written about domain-driven design, absolutely focuses on one extremely important aspect. Design phase is more important than the implementation phase. Jack W. Reeves, many, many years back, wrote a paper called as Code as Design. And ever since, every single decade, somebody writes something that becomes a really important part of history, continues to emphasize we are engineers. And design is equally important part of our roles and responsibility as is to write code. You would not like to write code if that code is getting messier and messier day by day. You would like to come every Monday morning and write code in a repository or in a code base that feels nice to write in. With that, I have these 2 QR codes up. I have written all these definitions down with some diagrams as well in this first blog. And I've written down a very extensive evaluation criteria in this second blog, which talks about all the benefits you're going to have, all the costs you're going to incur, and all the enablers you're going to need on an ongoing manner. With that, thank you. And I'm open for Q&A if there's any.
We've got 5 minutes or so for Q&A. If anyone want to ask Garima a question? No?
I can see one there.
Yep.
Do you find bindings just naturally evolve into your final diagram?
Can you say that again? Sorry.
Do you find bindings just naturally evolve into your final diagram?
No, and I'm very happy they do not, because they have, there's a bit of history about bindings itself. Come find me, it's going to take a longer time than my answer here. But as we adopted from where we started, we've adopted practices that have worked for us. And we're still on a path of continuous improvement. So we are adopting practices that work for us, and we are not that do not.
Thank you.
I saw one person raising their hand there.
Whereabouts? Over here.
At Bunnings, do you have a good way of updating MFEs independently?
What did you say independently? I didn't hear the...
Your MFEs at Bunnings, is there a good way of updating them independently rather than having to update every React version in each MFE at the same time?
So we actually do not have micro frontends at Bunnings. I have worked at ThoughtWorks, where I've been lucky to work at multiple clients where I've seen micro frontends. And where I did, in most of the scenarios, we had independent code repos. And what they were doing was they were also having React. And essentially, there was a automatic check that used to run on every repository to ensure the version is latest or latest minus one. Latest minus minor one, not major one. So that would enforce and inform the team if they're running behind.
Would you be running 2 versions of React that have to be sent down the wire?
So in the company that we were talking about, yes, that was happening. But what they were doing was they were consolidating it with the major version that the whole company adopted. And because React, by the nature of its code base, is backward compatible, it was not letting anything break. They hadn't, when I was there, they hadn't adopted module federation by Webpack, and they were exploring that pattern. In fact, what they had done was something where they had figured out how will they consolidate all these micro frontends into a singular one. But for them, just having the common React version was working due to the backward compatibility.